Okay, can you hear me?
Boleh.
Boleh. Okay, so for today's we will finish uh or topic 4, right? So for today we will look on the last subtopic for topic 4, which is test of independent or chi-square test. Alright, so for last topic, okay, is last subtopic is test of independence or chi-square test. Okay, so another name for test of independence is chi-square test. Okay, so for chi-square test, okay, we want to analyze the categorical variable or independent test in particular deals with testing the independence between two categorical variables. Okay, so previously, as we know, for case ANOVA, okay, we want to test between one categorical and one numerical data. Okay, but for chi-square test, okay, we want to test the for both variable is in categorical variable. Okay, so if you have both variable, okay, variable first and the second one is uh, in categorical data, so you can use test of independent or chi-square test. Okay, so these are the assumption for chi-square test. Okay, the first one is the data obtained from a random sample, and then the second one is the expected frequency in each cell must be 5 or more. So expected frequency we denoted as E. Okay, right. So this is our expected frequency. Okay, so how to find expected frequency, I will show you later. Okay, and then uh, if the if the expected frequency are less than 5, it should be combined category. So if you have the value for your expected frequency is less than 5, you need to combine, either you combine your row or combine your column. So I will show you later how to combine the value for your expected frequency or expected value. Okay. And then kat sini the statement say that to test the null hypothesis that the two characteristics of the element of a given population are not related. So we want to test whether the first and second variable is related or not related. Okay, so kat sini the another statement is the test of independence is performed using the contingency table or cross tabulation. Okay, as we know, if you remember in topic 2, okay, for presentation of data or graphical of data, we divided into two types of data, either categorical or numerical data. So if the case is on categorical data, so you can present your data using frequency table, okay, or cross tabulation table, or pie chart or bar chart. Okay, so cross tabulation termasuk dekat dalam case apa nama itu categorical, since we have two categorical variable. Okay, so you can use histogram or stem or leaf plot or box and whisker plot. Okay, since your data is in categorical. Okay, and then to test your hypothesis using test of independence, so you will use chi-square distribution. Okay, so previously for ANOVA, you use F distribution. Okay, for population mean, when you have two population mean or one population mean, so you will use Z or T distribution. But for case chi-square test, you will use chi-square distribution. Okay, so how to write your chi-square? Okay, so first step is you write a straight line macam ni, and then you write a curve macam ni, then you squarekan dia. Right, so dia bukanlah x besar ataupun x macam ni, tak, dia adalah straight line and then you curve. Okay, so this is the correct way how to write your chi-square. Okay, so this is the introduction for test of independence. Okay, so the next one, we will look on the steps, okay, how to solve the chi-square test questions. Since we know that for topic 4, we cover on hypothesis testing. So as we know, to answer the questions for hypothesis testing, you need to do all the steps from your hypothesis until your conclusion. Okay, so same goes to test of independence. So you need to write your hypothesis, your test statistic using p-value or chi-square calculator, and then your critical value, decision rule, decision, and also your conclusion. Okay, for hypothesis, for chi-square test or test of independence, so for hypothesis, your hash null, okay, and hash one, your hypothesis should be in sentence. Okay, dia dah tak adalah dalam symbol equal ke unequal ke tak. Okay, it should be in the sentence. So for your hash null, okay, so the variable are independent or no association or no relationship of each other. Okay, so for hash null is always no relationship. Okay, tak ada kaitan tu dia akan duduk dekat your hash null, while for your hash one opposite to your hash null. For example, if the question asks you either the two variables are independent of each other, so your hash null should be independent and your hash one should be dependent. Okay, if the question asks you is there is either the first variable has a relationship with the second variable, so even though the question asks you about has a relationship, but in your hash null you still write the first variable has no relationship to the second variable, and then your hash one, the first variable has relationship to the second variable. Okay. If the question asks you about association, so you use the correct apa nama itu, the correct sentence lah. Okay, ikut questions. Sama ada the question ask you about the independent, the relationship or no association. Okay, so that is for the first step. And then the second step is your test statistics. So sama for this case, you can use either chi-square calculator or also you can use p-value. Okay, so if you use p-value, so just go to the decision rule, reject hash null if p-value is less than or equal to alpha, then you compare p-value and alpha, and then some other reject to or fail to reject your hash null, then your conclusion. Okay, but if you use test statistic, you calculate your chi-square calculated, so this should be the formula, the summation of observed frequency minus expected frequency square over your expected frequency. Okay, so another name for your observed frequency or count, okay, if you look on your SPSS output, okay, so the value should be this one, count. Count is your O, observed frequency, while another one is your E, your expected frequency or expected count. So dia akan duduk yang dekat bawah ni lah. So this is your O, this is your E. Okay. So to find the value for your E, okay, your expected frequency, since the O, the observed frequency or count is your data, your original data, but the expected frequency, you need to find the value. Okay, so how to find the value for your E? The formula is, to find your E, your total row times with total column divide by sample size. Okay, so this is how to find the value of E. Okay, and then you substitute the value for E in the formula. Okay, then you will get the value for your chi-square calculated. And then the next one is your critical value. So for critical value, we will use chi-square alpha and then your degree of freedom. So this is how to find your degree of freedom, which is your row minus 1 times with your column minus 1. How many row? And then you minus 1. Darab dengan how many column? You minus 1. Okay, so for value for your chi-square calculated, if you look on your chi-square distribution, so the case is the same as F distribution. We only have a positive value, okay, for the positive side. So to find the value for your chi-square calculated, make sure the value is always positive. Okay, kat sini the value for your chi-square should be positive value. Okay, so if you calculate your chi-square calculated, you get negative value. So there must be something wrong with your calculation. Okay, so nanti you kena check balik lah. Okay, so for your critical value, so this is how to find the value. Okay, so degree of freedom is row minus 1, column minus 1. How many row? Minus 1. How many column? Minus 1. For example, in this question, so our row we have 1 and 2. Okay, so 2 minus 1. And then our column we have 1, 2, 3. Okay, so 3 minus 1. So 1 times with 2. So your degree of freedom is 2. So kat sini dia akan jadi nanti alpha 2. Okay, so to find the value of your critical value, so if you look on your X distribution, you have your alpha and your degree of freedom. So jadi macam biasa lah. Kalau 0.05, so 0.05 and then your degree of freedom berapa. Okay, so that should be the value. And then the next one is your decision rule. So for decision rule, reject hash null if chi-square calculator is more than chi-square degree of freedom. Your critical value. Okay, so kalau chi-square calculator is more than your critical value, so you will reject your hash null. So you compare for both value and then your conclusion. So in this case, dia ada special case sikit untuk for test of independence. For example, if you write your decision, okay, when you test your hypothesis, you make a decision. Let's say you reject your hash null. So when you reject your hash null, you say that the variable are dependent or has an association or has a relationship of each other. So you can directly write the conclusion. So this is your conclusion. Okay. So if the case you get fail to reject hash null, so you will directly write your conclusion is this one. Boleh. Okay. Or you can refer to the question either there is enough or not enough evidence. Pun boleh. Okay. Either one lah. But for conclusion only apply on test of independence lah yang you boleh tengok terus. Reject, this is your conclusion. Fail to reject, this is your conclusion. Okay. So for ANOVA or apa nama itu population mean, you still cakap there is enough or not enough evidence. Okay. So itu adalah untuk the step how to answer the question for test of independence. So before we look on the example, okay, so we will look back on the whole topic for topic 4. For example, we have one population mean. Okay, so we know that the question for one population mean, the question will ask test at 5% significant level. For example, if mean of satisfaction is more than 5.0, for example. So if the question asks you either the mean satisfaction is more than 5. So when we have a value, so we know that this is the case for one population mean. So when you write your hypothesis, it should be mu is equal to 5, h1 mu is more than 5. Okay, so that is the question for one population mean. Okay, and then make sure the keyword is the question will ask you to test. Okay, test at how many your value for your alpha. Okay, but if the question asks you to construct 95% confidence interval, so for that question you need to find your lower and your upper limit only. Okay, no need to do all the steps from hypothesis until conclusion. Okay, so that is the first example for one population mean. And then the second one, if the question asks you to test at alpha 0.05 is if there is a difference in mean satisfaction towards library between gender. So in this case, we know that gender, we only have two population. Okay, we have male and female. So since we only have two population mean, so we will apply independent sample test. Okay, so when you write your hypothesis, your H9 should be mu1 is equal to mu2. So H1, it should be mu1 is unequal to mu2. Okay, so that is the case for independent sample. But if the question asks you to test about the paired difference, okay, so bila paired difference, we know that that is the case for dependent. So you will compare your mu d. Okay, either the mu d is equal to your mu naught and mu d is unequal to your mu naught. Your mu d naught. Okay. So that is for dependent. And then for ANOVA, okay, for example, the question asks you to test whether there is a apa nama itu significant level at 5% significant level, is there is a difference, okay, in mean satisfaction towards library between faculty. For example, we have more than two population mean. Okay, kita ada the first faculty, second and third faculty. So we know that in this case, we cannot use two population means for independent. Okay, so you need to use one way ANOVA. So when you write your hypothesis, so kita kata mu1 is equal to mu2 is equal to mu3, and then for H1, we say that at least one pair of treatment means are differ or unequal. Okay, so that is how to answer the question for ANOVA. Okay, so yang ni nanti you betulkan balik. Kat sini you cakap at least one, at least one treatment mean. One treatment means are differ. Okay, ataupun at least one pair of treatment means are differ. And then the last one is for test of independent. For example, if the question asks you to test at 5% significant level whether gender is related to eye color. So in this case, okay, we have two categorical variable. Okay, gender is categorical, eye color is categorical. Kalau in this case, the difference in mean satisfaction toward library between faculty, so this is categorical, but mean satisfaction is numerical. So you need to use ANOVA. Okay, since we have one categorical and one numerical data. But if you have both variable is categorical, so you need to solve the questions using independent sample test or chi-square test. Okay, so for example, in this case, at 5% significant level, test whether gender is related to eye color. Okay, so as we know, for H null, your hypothesis must always be no relationship, tak ada kaitan. Okay, even though the question asks you to test whether gender is related to eye color, but you must write this sentence in your H1. Gender is related to eye color. Okay, so for your H null, gender is not related to eye color. Okay, so you have one, the first and the second variable, and then the relationship too, not related and related. Okay, so if the question asks you at 5% significant level, test whether gender is independent. So if the question asks you either the gender is independent, so you need to use independent lah. So as we know the independent has no relationship, it should be in your H null. And for your H1, it should be dependent. Okay, refer to the question. If the question asks you at 5% significant level, test whether gender is associated to eye color. So kat sini kita kata gender is not associated. Yang this one dia akan jadi associated. So follow the question. Okay. So janganlah the question tanya whether gender is related to eye color, tiba-tiba you buat gender is independent to eye color. So dia tak kena lah. Okay, tak jawab the questions. Okay. So this is how to write your hypothesis for test of independent. Okay. So now we will look on the example, okay, for test of independence. So for example 4.16, so the question said that a random sample of 400 people is selected from all the 16 years old in the town. So the variables recorded were temper, val or mile, and hair color are red, brown or black. So we have two categorical variable, which is temper and also hair color. So the observed frequency are displayed in the table below. Test the hypothesis that temper and hair color are independent. So the question asks you to test whether temper and hair color are independent. Okay. So if you look at the questions, you already know that we have our first and second categorical variable. So automatically you know that this is the question for test of independent or chi-square test. Okay, since we have two categorical variable. So for temper you have val and mile, and then for hair color you have red, brown and black. Okay, so how to solve these questions? Okay, so we know that to solve the questions you need to do all these steps, okay, from step 1 until step 5. So for first step, there is no problem, okay, since the question asks you to test whether temper and hair color are independent. So for your hypothesis in H null, what should be you write in your H null? In this
The variables are independent of one another.
Alright, okay. So you can just write the questions pun is okay. Okay, kita just kata temper and hair color are independent. Okay, and then for your H null, the opposite for the independent, we said that temper and hair color are dependent, right? So this is how to write your hypothesis. And then the second step is your chi-square calculated. So how to calculate your chi-square calculated, you will use this formula, okay? But before that, okay, so in the questions, okay, since the question only give you this table, okay, this raw data, so the value in this raw data is your observed frequency, okay, your O. Okay, so this is the O for violet. This is the row the observed value for mild red. Okay, so now the missing value yang you tak ada is your E, your expected frequency. So how to find the value for your E? So you need to find E for each row and column. Okay, you need to find the value for your E. So how to find the value for E? Okay, this is the formula. Total row times with total column over your sample size. Okay, so now you need to find first your total for each row and total for each column. Okay, kita cari dulu total row and total column. So untuk the first row for red, 40 plus 20, so you will get 60. Then this one 100 plus 80, 180, and then this one 160. And then you find for each column, so 40 plus 80 plus 60, so you will get 180. Then this one you will get 220. Okay. So then barulah you akan dapat your total row should be equal to your total column. Okay. So the value should be 400. So this is your sample size. Okay, your total sample size. Okay. So we already have our total row, total column and sample size. So the formula for E is total row times with total column over your sample size. To find the E for violet and red, so you need to times your total row times with your total column divide by your sample size. So maksudnya 60 times 180 over 400. So you will get the value for the expected frequency for this one. So nanti you akan dapat this value 27. And then for this column and row, so you just darabkan je lah 60 times with column. So now 220 over with your sample size 400. So nanti you akan dapat this value 33. Okay, so sama juga untuk brown. So 180 times with 180 over 400. So you akan dapat this value. Then for this one, sama 180 times with 220 divided by 400. So you will get this value and same goes to the last row, right? So now you already have your observed and expected frequency. Okay, so first you need to check, okay, either the value is correct or not. So if you add 27 plus 33, so you will get the same value, 60. So sama juga untuk ni, 81 plus 99, you will get 180. 72 plus 88, so you akan dapat this value. Sama juga bila you tambah these three value, you akan dapat 180 and 220. Okay. So kalau the value is same, so tak ada masalah lah, memang that is the correct value for your expected frequency. So once you already have your observed and expected frequency, so you need to substitute into the formula. So we know that the formula for our chi-square calculator is the summation of your observed minus expected frequency. You square the value and then over your expected frequency. So now we have 1, 2, 3, 4, 5, 6. So you need to add all these value. Okay, you will have 6 value. Okay, so tak kisahlah you nak guna, you nak buat this value ke bawah dulu and then baru this one ke bawah ke, tak kisah, asalkan as long as you have 6 value. Okay, so macam mana nak buat dia? Kita tengok untuk the first one. So your observed frequency is 40. So 40 minus with expected frequency is 27 square over 27. This is the first number. And then the second one, you can choose either 80 minus 81 square over 81 or 20 minus 33 square over 33. Tak kisah mana-mana, right? And then the next one, plus 100 minus 9 square over 99. Over 72, and the last one is 100 minus 88 square over 88. So make sure you have 1, 2, 3, 4, 5, 6. Okay, 6 value. Okay, and then you need to find the value for this one, right? So here, what will be your value for your chi-square calculated? So if you have 8 values, so you need to list all the value, okay, and then you find the final answer. Okay, so you write your value for your chi-square calculated in 4 decimal places.
Fifteen.
15.0393. Sama.
Okay,
Bye-bye.
15.0393. Okay, good. Okay, so this should be the value. Okay, so this is your chi-square calculated, and then the next step is your critical value. Okay, so you know that for your critical value is chi-square alpha, and then your degree of freedom is rho minus 1, column minus 1. Okay, so this should be your critical value. Okay, this one bukannya koma, value ni koma tau. This one you kena darab dulu this value. Okay, so the question asks you to test at 5% significant level. So kat sini it should be 0.05. And then your row, so kat sini row kita ada 1, 2, 3. Okay. 3 minus 1. And then your column, you have 2 mile and a val, so 2 minus 1. Okay, so kat sini dia akan jadi 3 tolak 1, 2, 2 darab dengan 1, 2. Okay, so this is your degree of freedom, 2. Okay, then you need to find this value. So how to find the value? This is your alpha, this is your degree of freedom. So if you look at your chi-square distribution table, so the value for your alpha, it will start with the large value. Okay, larger value to the smaller value. Okay, so in this case, you need to find the value for 0.052. Okay, so 0.05, so this is your alpha, and your degree of freedom is 2. So this should be the value. Okay, 5.991. So this is the value for your critical value. Okay, so the next step is your decision rule. So for the decision rule is fixed. You reject your H0 if chi-square calculated is more than your chi-square critical value. So decision rule, reject H0 if chi-square calculated is more than your chi-square critical value. Right? And then you need to compare the value for your chi-square calculated and also your critical value. You will compare these two. So we said that since chi-square calculated 15.0393, so this value is more than your critical value. So you will reject your H null. Okay. So as I mentioned before, okay, for your conclusion, okay, you can just directly write the conclusion for in this case, for example, reject H null. So bila kita reject H null, we say that temper and hair color are dependent. So for your conclusion, you can write temper and hair color are dependent. Boleh, okay? Or you can also write your conclusion, as we know that the question asks you either temper and hair color are independent. So this is the question. But when we test, we reject our hash now. So we say that the hair color are dependent. So if you want to write your hypothesis as your conclusion, you also can write there is not enough evidence to conclude that temper and hair color are independent. Okay, so you can write your conclusion. Okay, once you get reject hash now, so you just directly write this as your conclusion, or you can also write there is enough or not enough evidence. Okay, refer to the questions. Okay, so this is how to answer the questions for chi-square distribution. Okay, so okay tak? Senang kan? Boleh?
Dapat.
Okay.
Alright. So this is the example. If the questions only give you a raw data, okay, you do not have a SPSS output. Okay, so now we will look on the example where the question give you the SPSS output for test of independent or chi-square test, right? So this is the example. Okay, the SPSS output for test of independent or chi-square test. So once you look at the output macam ni, okay, ada kat sini tulis chi-square test. So we know that this is the case for test of independent or chi-square test. Okay. So kat sini the question say that a random sample of 100 patrons from 3 different restaurants, each of which serve breakfast, lunch and dinner, will ask which meal they purchase. So the result are shown in the table below. So kalau you tengok on the first table, so this is your variable, the first and the second variable. Okay, meal and restaurant. Okay, so this is your first and your second variable. So this one is uh, meal and restaurant. Tak kisahlah yang mana satu yang mana dua. Asalkan ada dua lah. Okay, variable you. So for meal we have breakfast, lunch and dinner, and then for restaurant we have A, B and C. So if you look at this SPSS output, you have count and expected count. So this is your O and your E. Okay, so no need to find the value for your expected frequency since the value is already there. Okay, dah bagi dah. Okay, so make sure you just tengok these 3 row. Okay, this is for your total. Yang ni dia tak termasuk. Okay, this one pun sama kolom. This is for your total. Okay, so yang ni tak termasuk. So bila you will need to find your degree of freedom. So your row column -1. So your row just 1, 2, 3, not 1, 2, 3, 4. Okay, so make sure betul-betul lah you tengok. Okay, so in this case, so this is your O, this is your expected frequency, and then for chi-square test, we only look on the first row. Okay, Pearson chi-square. Okay, yang another two ni you just ignore the value. Okay, so the value for this one, okay, this is for your chi-square calculated. This is the value. And your degree of freedom here is refer to row -1, column -1. So in this example, if the question asks you to show that the degree of freedom is 4, so kat sini bila kita tengok 3 tolak 1, 2, 3 tolak 1, 2. So 2 times 2 is 4. So you boleh show lah the degree of freedom. And the last one is asymptote significant, two-sided. So this is the value for your p-value. Okay, the last column is your p-value. So your p-value no need to times or divide by 2. Just take the value. Okay, so that is your p-value. Okay, so usually if the question give you the SPSS output for independent test of independent or chi-square test, usually the question asks you to to find the missing value, okay, in the table. So if the question asks you to find the expected count, okay, you need to use the formula, okay, yang total row kali total column over your sample size. Okay, you have the value for your total row and total column. Okay, so just take the value, right? So this is how to read your SPSS output for chi-square test. Okay, and then the question asks you to calculate the value for A, B, and C. So for A and B is the value for your expected frequency. So you need to use this formula. While for C is your chi-square calculated. So you need to find using this formula. Okay, substitute the value. Right, so for first question, for value of A, so we know that the value for A, your total row is 113 and your total column is 100. And then divide by your sample size is 300. Okay, so 89. Okay, 89 times with, betul ke ni? Okay, terbalik Only 113. 113 times with 100. 113. Okay, 113 times with 100 and then divide by 300. So in this case, to find the value for your A, you need to refer to the decimal places in the output. Okay. So in this case, kalau you darab 113 times 100 over 300, you dapat berapa value?
37.6667. If
Nanti yang
we
6667, alright. But if you use this value, if you add up to 37.7 plus 37.7, so you will not get exactly this value. Okay, so how to find to write your value for A? So you just need to round off to one decimal places. Okay, follow je the decimal places of the output. So the answer should be 37.7. Okay, just use one decimal places. Okay, if your output use two decimal places, so you use two decimal places. Okay, supaya bila you add up all the value, you will get the exact value. Tapi kadang-kadang the value tu dia lari jugalah sikit-sikit. Okay, tapi tak apalah, as long as you use the correct formula, so that's okay. Okay, so that is the value for A, and then the value for B. Okay, so for B, we take this value 89 times 100 over 300. Okay. So 89 times 100 over 300. So nanti you will get the value is 29.7. So sama, you just take one decimal place. Okay. So that is the value for A and B. So now, to find the value for C, so we know that we need to use this formula. Okay. And we already have the value for your observed and expected frequency for each column, okay, row and column. So you need to have 4, 5, 6, 7, 8, 9. Okay, you can ada this 9 value lah, right? So you find the value. So 26. Okay, so 26 minus 32.7. So you just ambil je value ni hang. Okay, ni O ni E, ni O ni E. Okay. So no need to no need to calculate the value for your expected since the value is already there. So value for A, you already get this value, so just minus the value lah. 37 minus 7 square over 37.7. Okay, then the next one. 3 minus 37.7. Then the next one, 21 minus 44 minus 29.7 square. And the last one, 24 minus, so B is this value, 29.7 square over 29.7. Okay. And then you calculate the value. So what will be the value for your C? Dia dah dapat dah value.
I got 27.4696.
27?
27?
Wrong.
Oh,
29.6.
29.
Salah juga
is there an easier way to do this?
So another way, but apa nama itu, dia macam banyak sikit lah. You need to find each value and then you add up all the value. Tapi yang tu dia macam panjang sikit lah sebab you kena cari satu-satu and then you kena apa nama itu, add up all the value. So jadi macam banyak kerja lah. Ada tak yang dapat 25.3955? Ada tak yang dapat?
Ada.
Yeah. So that is the correct value.
Sorry,
25.3955.
sorry, come again?
29,
29?
25.3955.
3955. Okay, I'll calculate again later, I think.
Alright. Nanti you try what tak ada value. 21, 29. 44. Got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Nanti akan dapat itulah 25.3955. Okay, so that is for the first question. And then the second question, the question asks you to state the appropriate hypothesis to test whether the choices of restaurant is dependent on the type of meal selected by the patron. So the question only asks you about the hypothesis. So you just write your H null, since we know that for H null is always no relationship. Okay, tak ada kaitan. So in this case, your H null should be the choices of restaurant is independent of the type of meal selected by the patron, and your H null is the questions. Okay. Nanti this one you will get the value is 25.3955. Nanti you check balik the value, right? And then for question 2, the question only asks you to write the hypothesis. So for H now, just tulis sahaja, cuma you just tukar jadi independent lah. And your H1 should be the question. Okay? So we say that the choices of restaurant is independent of the type of meal selected by the patron. Okay, so this one independent, and then for H1, the choices of restaurant is dependent. So follow the question. If the question asks you either related or not related, so this one you use not related, related. Okay. Type of meal selected by the patron. Alright, so that is for second question. And then the last one, based on the p-value. So the question already mentioned the method, use p-value. What can you conclude about the claim? Use 0.01. So as we know that the last column is the value for your p-value, and the previous questions already asked you about the hypothesis. So to answer the question for the third question, you just start with the value of your p-value. No need to write back your hypothesis. Okay. So in this case, your p-value is 0.00, and your alpha is 0.01. And then the next one is your decision rule. We check H null if p-value is less than or equal to alpha. And then for decision, we compare these two values. We said that since p-value is equal to 0.000, so this value is less than your alpha, so you reject your H null. Okay, so for the last one, for your conclusion, so you can just write the choices of the restaurant is dependent of the type of meal select by the patron, or you can say that there is enough evidence to say that the choices of restaurant is dependent on the type of meal. Okay, you boleh pilih mana-mana je lah. Okay, ataupun you terus je buat reject hash now. So this is your conclusion. Boleh juga. Okay. So the choices of restaurant is dependent. Alright. So that is how to answer the question for example 4.17. Okay. So any question for example 4.17 boleh?
So far masih boleh follow.
Boleh.
Alright. Okay.
Ada
So dia
satu
kalau,
question, Miss.
apa dia?
Macam yang calculate A, B and C tu kan, kalau dia tak suruh calculate, boleh ke kita tulis je sebab satu row tu semua sama.
Satu row tu semua sama. Macam mana?
Dia punya expected count.
Oh, you just tulis 37.7.
Ya.
Tak boleh. You kena use the correct formula. Lagi satu, untuk nak dapatkan this value the value for A ni, okay. So since we know that A is your expected count, so you need to use formula. Maksudnya untuk nak kira A tu, you tak boleh nak buat 113 minus 7 point ni minus dapat 37.7. Tak nak. Okay, you use the correct formula. Since this is the formula for expected count, so we know that this is the formula. Melainkan that question asks you to find, for example, this value D. So this is the value for your observed frequency. Yang ni baru you boleh nak cari D. you kena 98 minus 29 minus 26. So you will get the value. 43. Make sure you show how to find the value. Jangan terus buat D is equal to 43. Tak nak juga. Okay. So untuk to find the value for your count, you just minus your total minus the value. Or you can also find the value of here, D ni, by minus 100 minus 24 minus 33. So you will get 43. Samalah, sama ada nak tolak yang ini ataupun nak tolak yang ini. But for expected count, make sure you use the correct formula. Buat macam ni. Tak nak tolak macam ni, tak nak. Okay, mesti use the correct formula. Okay, so itu adalah untuk nak find the value in your SPSS output. Okay, so kalau you check pun kalau 37.7 ni, kalau you tambah 37.7 tambah 37.7 dapat tak tepat-tepat 130. Itu ada lari sikit apa ni. Dia akan dapat 113.1. Dia macam lari sikit lah 0.1 tapi okey je as long as you use the correct formula. Okay. So itu adalah macam mana nak find the value. So okay tak? Okay ke tak okay?
Alright, Miss.
Alright.
Miss, we compare the p-value with the alpha and not the critical value?
Which one? This one?
The last one.
This last one?
Yeah. The decision rule?
We compare reject now if p-value is less than or equal to your alpha. Since now we look on the p-value, okay? But if the case do not mention about any method, they just kata what can you conclude about the claim? Okay, so you can use this one. Okay, so you can use your chi-square calculated. Okay, 25.3955. But you need to find your critical value. So you need to find 0.01. So your degree of freedom is there, 4. Okay, 0.01, 4. For this should be the value, 13.277. Okay, and then your decision rule, we said that we reject our hash null. Reject hash null if chi-square calculated is more than your chi-square critical value. And then we compare this value. Since this value is more than this value, so you reject your hash null. So for p-value, you cannot compare with your critical value. P-value only compare with your alpha. If you use chi-square calculated, then baru you boleh compare with your critical value. Okay, so kalau you compare this value with this value, dia dah jadi salah lah. Okay, dia jadi wrong lah. Okay, boleh?
Alright, thank you.
Alright. Okay, so kalau macam yang ni A ni kan, kalau you tolak, you memang akan dapat dia punya value tu tepat-tepat lah. You akan dapat 130. Okay, tapi macam I kata, if the question asks you about the expected count, make sure you use the correct formula. Okay, so itu adalah how to answer the question for chi-square test. Okay, and the last one, okay, last example. So for this example, okay, so actually when you have a SPSS output, okay, as we know that the assumption for chi-square test, okay, for the second assumption, okay, the assumption say that the expected frequency for each cell must be 5 or more. So you need to check first the value for your expected frequency. Okay, so in this case, since all your expected value is more than 5, so there is no problem. Then goes to this example. So if you look at the example, the value for A and B is also 5 or more than 5. Okay, so there is no problem. Okay, but in the next example, example 4.18, so in this case, if you look at your expected frequency, okay, so there is one expected frequency that is less than 5. Okay, we have 3.3. So what you need to do is, okay, as the assumptions say that you need to combine the categories. Okay, so how to combine the categories? Okay, you need to check. Okay, so in this case, you cannot combine your column. Why? Since you only have two column. So bila you combine these two column, pass fail ni jadi satu kategori. So you akan jadi ada satu saja, akan ada satu column. So when you only have one column, so when you want to find your degree of freedom, so as we know that the formula is row minus 1, column minus 1. So if your column, you combine these two column, so it should be one column. So dia jadi salah lah, 1 + 1 kosong. So there is no degree of freedom. So tak boleh lah. Okay, you cannot combine the row or column that has only two category. Okay, so in this case, since we cannot combine fail with pass, so we can combine satisfactory with poor. Okay, you akan combine these two category as one. Okay, dia akan jadi satu. So dari from 3 row, dia akan jadi 2 row. Since you combine the two row jadi satu. Okay. So kita tengok this example 4.18. So the attendance and examination of a random sample of pupil are given in the table below. So the data were analyzed using SPSS and the output are as follows. So this is the first variable, attendance, and the second example is exam result. Okay, so this is your SPSS output. You have excellent, satisfactory, and poor, and for exam result you have pass and fail. Okay, and then this is the chi-square test. So your chi-square calculated, your degree of freedom, and your p-value. Okay, so in this case, okay, the attendance and examination of a random sample of 60 people are given in the table below. The data were analyzed and the output, and then find the value of K and L. So you need to find the value for K and L. Okay. So dalam case yang ini, okay, so untuk K ni tak ada masalah. You just use the the formula. 35 times with 40 divide by 60. So you will get the value for your K and just write your value in 1 decimal places. Okay, since the value kat sini hanya 1 decimal places sahaja. Okay, so K tak ada masalah. So for A, to find the value for K, just times your row with column. Okay, so you will get the value is 35 times with 40 over with 60. So you will get 23.3. Okay, so this is the value for your K. But now the problem is for your chi-square calculated, since we know that there is one expected frequency that less than 5, so you need to combine either your column or your row. So in this case, we cannot combine our column, since if we combine our column, it will be only one column. So tak boleh lah. So we will combine satisfactory and poor. So how to combine the SPSS output ni? Okay, dia akan jadi from here, okay, daripada sini. So kita akan ada attendance tadi. So attendance, kita ada excellent. Okay, and then ni kita ada exam result. So exam result ni kita memang tak boleh nak buat apa. We just take the pass and fail. Okay. So this one. So dia akan sama je lah, the observed and expected frequency. Okay, kita akan just follow saja 25 and then K tadi we get 23.3 and then for fail 10, 11.7. And then untuk kita punya total, dia akan sama je lah, 35 and then 35.0. Okay, but now the problem is we want to combine the satisfactory and poor, since our expected frequency is less than 5. Okay, so kita combine this row, so dia akan jadi kat sini nanti satisfactory times with poor. Okay, so the value for your observed and expected frequency, you just add the value. Okay, for here the count should be 10 plus 5. So So dia akan jadi kat sini value dia adalah 15. And then for your expected count, you just add 10 with 6.7. So kat sini dia akan jadi 16.7. Okay, and then for your fail, so samalah, you just add 5 time with 5 add with 5, so we get 10, and then 5 plus 3.3 jadi 8.3. So the total should be 25, and then this one you akan dapat 25 lah. And then this one you akan tambah nanti total you akan dapat 40, and then this one you akan dapat 20. So the grand total, your total for this one, dia akan dapat samalah 60. Alright. So from 3 row, 1, 2, 3, now you only have 2 row, 1, 2. Okay, and your expected frequency now, it will be more than 5. Okay, 8.3. So there is no problems lah. Okay, then barulah you kira your L. So to find your L, you just have 1, 2, 3, and 4. Okay. So how to find the value? So just put je lah 25 minus 23.3 square over 23.3 plus 10 minus 11.7 square over 11.7 plus 15 minus 16.7 square over 16.7, and the last one 10 minus 8.3 square over 8.3. Okay, so this is how to solve the problem. Okay, if you have your expected frequency is less than 5, okay, you need to combine the value. Okay, so nanti you akan dapat the value for your L. Okay, so kira what will be the value for your L?
0.8923. Same with Ardam. Is that right?
Alright, so 0.8923.
Yeah.
Right, alright, so this
Alright.
is the value. Alright, so if you look at the chi-square task, okay, so in this degree of freedom, so the value of 2 is actually refer to this column. Okay, so in this case we just ignore. So supposedly the questions do not give you the value for this one. Okay, dia sepatutnya dia bagi yang table memang degree of freedom dia 1, since dia dah combine the table actually. Okay, tapi you just ignore saja. Okay, so this is how to answer lah bila your expected frequency is less than 5. Okay, so this is the value for your K and L, and then for B, state the null and alternative hypothesis for this study. So in this case, if the questions only ask you about the null and alternative hypothesis, so how to find what is your hypothesis? So you need to check with the next questions. Okay, so in this case, by using p-value, test at 5% level of significance whether examination result is independent of attendance. So your hypothesis for B should be this one lah. Your hash now, examination result is independent of attendance, while your hash 1, examination result is dependent of attendance. Okay, so for B, just write the questions. Okay, so examination result is independent of attendance, and then for your H1, examination result is dependent, okay, of attendance. right? So that is for B. And the last one for C, by using p-value. So the question asks you to use p-value. So this is the value for your p-value. So you just use that value. So for C, terus you directly write your p-value. So the value is 0.448 and your alpha is 0.05. So if the questions do not give you the value for your alpha, okay, for example, in this question, dia kata based on the p-value, what can you conclude about the claim? So there is no alpha. Okay, so if this is the case, you use alpha at default. Okay, 0.05. So kalau question dia tak mention je pasal alpha, so you guna 0.05. Okay, tapi kalau question dah mention, so you guna je lah alpha yang diberi. Okay. So kalau dia tak bagi, you guna at default. Okay. And then your decision rule, we said that we reject hash now if p-value is less than or equal to alpha. Then we compare our p-value with our alpha. We said that since p-value 0.448, so this value is more than your alpha, so we fail to reject our hash null. Okay. So sama macam biasa, to write your conclusion, since we fail to reject our hash null, so conclusion just write examination result is independent of attendance. Or you can also write, since the question asks you either examination result is independent, so you say that there is enough evidence to conclude that examination result is independent of attendance. Okay, mana-manalah sama sahaja. Examination result is independent of attendance. Okay, so this is how to answer the question for example 4.18. So now we already finished our topic 4, right? So we only have the last topic bivariate analysis. And then for the last topic tu memang we only need 2 hours, then we finish the chapter, okay, the topic. Okay, so nanti you can try tutorial questions, okay. So nanti I will assign students to do the tutorial questions for ANOVA and test of independence. Okay, so nanti in the next class we will discuss on the tutorial before we continue to the new topic. We proceed to the new topic, okay. And then for tomorrow's class, okay. So untuk kelas esok, so saya tak nak buat kelas. Okay, so what you need to do is, okay, I will upload a video, okay, my previous video on SPSS output. So you download you install the software, okay. You, if you do not want to use the trial, so you can apa nama itu, get the link from me, okay, to install the SPSS software. And then you can try apa nama itu, use your SPSS software, follow the video that I upload later. Okay, yang itu memang I dah bagi the whole video on how to apa nama itu, how to insert your data from Google Form, you convert to apa nama itu, Excel, and then from Excel how to convert your data in SPSS. So you can try first. Okay, if you have any questions, so nanti next week, okay, kita akan buat satu kelas untuk SPSS. Okay, maybe next Thursday kot. So on Wednesday we discuss and finish our syllabus, and then on Thursday we will discuss on SPSS software. Okay, so nanti tengok dulu macam mana. Okay, so nanti I will upload the video, so you boleh try dulu. Okay, apa, run your data, okay, convert from Google Form to Excel, and then from Excel to your SPSS. Okay, so nanti you can try, and then you can try run the data. Okay, follow the video. Okay, so if you want to know about the additional notes on the SPSS, okay, so you can refer to this note. Okay, I already upload on Google Classroom, but in this note, okay, the note apa nama itu, show you how to insert manually the data. Okay, maksudnya you masukkan satu-satu. Okay, bila ni you masukkan, okay, satu apa, dua apa. Tapi in your case, since you dah ada data tu dalam Google Form, so nanti you nak transfer daripada Excel to SPSS, so nanti you boleh follow lah video yang I tunjuk tu. Okay. So nanti kalau you have any questions, so nanti kita akan jumpa maybe next week kot, on Thursday. So nanti yang tu memang kita buat one class untuk SPSS software saja. Right? So, are there any questions before we end our class? Boleh? Boleh tak? So mana yang nak link tu nanti you can list your email on group. Okay, in group. So nanti I will email you the link.
Okay, Miss.
Alright. So if you have no questions, so thank you for
Miss, nak tanya.
Ha.
Regarding the last example.
Okay, this one.
So for this question, we have to use the p-value.
Yes.
What if they ask to use the chi-square distribution?
Okay, so if you want to use chi-square calculated, so in this case, so you will use this value. Okay. Okay, this value, so chi-square calculated, okay, 0.923. But in this case, you can use the degree of freedom for this one. Okay, since you already combine the table, so your chi-square, it will be this one. Your row is 1 minus 1.
2 minus 1?
2 minus
Isn't
1.
it? We have 2 rows and 2 columns for the new table. Okay.
2 minus 1. Okay. And then this one pun dia akan jadi times with 2 minus 1. So dia akan jadi
So it's
1 lah.
1. Yep.
So dia akan jadi value. Okay, so nanti bila you read from your statistical table, so 0.051, so this is the value, 3.841. Okay, 3.841, and then you test the value, you compare. So we say that since our chi-square calculator is less than our critical value, so we fail to reject our H-null. Okay, so nanti your conclusion, you will get the same result. Okay, examination result is independent of attendance.
Okay, so the critical value will be based on the new table that was formed?
Yes.
Okay. Okay, I got it. Thank you.
Alright. Okay, so if you have no questions, so thank you for today. So don't forget to fill up the attendance. So for tomorrow's class, we have no class. So you can refer to the video later. Okay, I will upload the video and you try first. Okay, your SPSS. Either you can run or not. Okay, your SPSS. So if you have any problems, you can ask me later. Right? Right. So thank you for today.
Okay, thank you, Miss.